All right, hello everybody. So let's do number 2 from the sample exam. It's also number 4.44 on homework 6, or at least very similar to. So let's get into it. So we have this circuit, and there are 2 voltage sources on either side and a current source on the bottom, and then these 5 resistors. I kind of feel like a weatherman looking at myself in this camera. But there are 5 resistors in this arrangement, and we're asked to find the current going from top to bottom through this 40 ohm resistor. And we're asked to do that with mesh current analysis as opposed to nodal voltage analysis. So we're not going to assign a voltage. We're not going to label a voltage on these nodes and then use the currents going out of them to find the voltages. Instead, we're going to assign mesh currents to each of the 3 meshes, and then use Kirchhoff's voltage law, which states, as I'm sure you remember, that the sum of the voltage around a closed loop is equal to 0. So if we have a closed loop, like say this loop over here, where it starts and ends in the same place, then the voltage drop across this resistor and across this source and across this resistor and across this resistor, given some current here, the sum of all that must be equal to 0. And you can think about this similar to gravity, if this is helpful for you, in that the electric potential that voltage is will be dropped and gained and dropped and gained, but it's a conservative field like gravity is. So if you start on the top of a hill here, then you go down and down some more and down some more. Eventually, you need to go back up, because just like in gravity, if you're going around a block, you're going to end up back at the same height that you started at. And it's a similar thing with the electric potential that is voltage. Okay, so let's assign our mesh currents. In the problem, it says to use clockwise sense. So we'll assign this mesh with I1. We'll assign this mesh I2, going clockwise. And now we can use clockwise or counterclockwise. The problem tells us to use clockwise in those 2 at least. But in this bottom one, I'm going to use counterclockwise. And that is because the source on the bottom is pointed to the right on the bottom. And I want our mesh current to be going in the same direction. If we're going the other direction, then we would need to make I3 the negative of the source, so it would be equal to negative 12 amps. But I want to just make things easy, go in the same direction. And so I3 is equal to 12 amps. And as we're doing the calculations, I'm just going to stick with 12 amps instead of I3. So that's the constraint. That's the constraint that gives us I3. Okay, so now we're going to use the KVL, Kirchhoff's voltage law, in these meshes to give us a system of equations and then solve for the currents. And now, why did we assign the mesh currents? Well, it's because we have a resistance, and for Kirchhoff's voltage law, we need a voltage. Well, the voltage drop across the resistor is equal to the current through the resistor times the resistance of the resistor. So if we assign a current, then we can find the voltage by just multiplying the 2. And then we'll use the passive sign convention with our sources to get the voltage around those loops through the sources. Okay, I'm going to erase some stuff, and then we'll work on loop I1. Okay, so I1. Let's get to it. Let's start up here at the top of the loop. So we have V equals IR. Our I is I1. Our R is 10. So I'm going to say 10 I1 plus, because we're summing up the voltage drops. 40 is the resistance here on this next one in the loop. But notice that we don't only have I1 going through the 40 ohm resistor. We also have I2 going up the other way. Excuse me. I2 is going up, it's opposing I1. So since we're dealing with I1, we're going to say we're in the direction of I1, but we have I2 going the other way through the resistors, so we're going to subtract I2 to give us the voltage drop across the 40 ohm resistor, the total voltage drop. Okay, now we have the 14 ohm resistor. So that's 14, and this time our I1 current is going this way, and the 14 ohm resistor is also getting the 12 amps, but it's in the same way. So we're going to add them. So this is I1 plus 12. Plus 12. And then finally our current goes through this 600 volt source, and we can see the current clockwise is going into the negative terminal of the source. So the passive sign convention says that it adds a negative to the voltage. So we're subtracting 600 volts, and all of that equals 0. So we have the sum of the voltage through each component in the loop, and that all is equal to 0. So now let's group these terms. So we have 10I1 here, 40I1 here for 50, 14 more I1 for 64I1. And then we have negative 40I2, and that's the only I2. And now we have this negative 600, and we have 14 times 12, which is 168. So we have plus 168 minus 600 equals 0. Okay, so 168 minus 600 is negative 432. I'm just going to replace that here. Minus 432 equals 0. And then let's divide this whole thing. There's a common factor here of 8. That'll do us some good. And so 64 divided by 8 is 8I1 minus 5I2. And I'm going to move this. I'm going to add 432 to each side, and then divide by 8. And that gives us 54. So our first mesh current equation is 8I1 minus 5I2 is equal to 54. I'm going to rewrite that up here, and then we'll work out the second current loop.